Now, in an effort to not repeat what you've already read in the lab notebook, I'm just going to show you the highlights of this experiment. Now, I realize that being at home and watching this on video is not near the level of excitement that you would attain had you been in lab to do this, but we'll try to replicate it nonetheless. So what we've done is we have two thermocouples and they're unknown to us. So what we've done is we've labeled each thermocouple orange and purple. Now, as I focus in on the polydac, this is our polydac system. The orange thermocouple is plugged into M1 and the purple is plugged into M2. And those are just two different channels that we can collect millivoltage coming off the thermocouple. So as in the notebook, or I'm sorry, the lab notebook, it shows that we put the negative end of the thermocouple into our ice bath, which is here, making sure the ends don't touch. And we put the positive ends that would be plugged into these two where it says positive, and we would take those and we put them in our water bath. Now, the purpose of this water bath is that we are going to calibrate these thermocouples using known temperatures. So we were going to start with room temperature water, which is measuring now at about 20 degrees C, and we're going to heat up the hot plate. And so as I turn the hot plate on, the water will slowly start to increase in temperature. Now, the way this works is as the water increases in temperature, the voltage in the thermocouple will increase because the temperature is increasing. But what we can do is we can use this glass thermometer shown here, and let's see if I can focus in on it. We can use, sorry, it's not too focused, but we can use this glass thermometer and we can measure the temperatures and then correlate that to voltages. So for example, right now, the polydac is running continuously. And so I'm going to tell the polydac that at this voltage, we have 20 degrees. So I'll have a corresponding voltage to a temperature. As the water heats up, each 5-degree increment, I will record the voltage again. So for example, when this reaches 25 degrees, I'll make sure to record the voltage on the polydac. When it reaches 30 and 35 and 40, all the way up to boiling. So what we're essentially using is a glass thermometer, which will have its own limitations, to calibrate this thermocouple. So in subsequent tests, as you can imagine, if you had an unknown liquid that was at a temperature between 20 and 100 degrees C, you could measure the voltage of that liquid, use your calibration curve, and find what that temperature is. So this experiment, had you been here, takes about 20 minutes to a half an hour for the water to heat up and to take each piece of data. I'm not going to torture you by having you watch it till it starts to boil. Rather, you'll get the data as a file showing you what the voltages are at each temperature. Okay? So at this point, I'm going to stop the camera and we'll pick up when we're done. Thank you. Now several minutes have passed, and as the water is heated up, I've been recording the voltage at each increment of 5. So we're almost at the end of the experiment here, and if I focus in, and you may or may not be able to see it, probably most likely not, but take my word for it that we're almost to 90 degrees. Now when we get to 90 degrees, we'll again tell the polydac that we're at 90 degrees, and there's a very easy way to do this. What we do is we come up to the polydac and we click on Tools and we say Earmark Data File, and what the Earmark Data File does is it allows you to put a note at any point you want. So if I type in 90C, then at the moment it's at 90C, which is just about now, and I click Add, then in that long string of data that I've been taking continuously for the last 15 minutes, it'll tell me the exact location where that voltage occurred. Otherwise, you'd have to go through thousands of lines of data, because we're taking it at every 0.02 seconds, to find that location. Now that's not as important for you at home because you're not doing the experiment, but it just is something that makes your life much easier on this end. So as I was saying, we're almost to the end. We're going to heat it till it boils, and then we're going to call it good. So that pretty much ends the experimental portion of this part. At this point, you'll be given the data and the instructions and the deliverable. And thank you for watching, and I'm sorry this wasn't a more professional video, but as you know, with the COVID, we're doing this on the fly. So I appreciate you watching.
The young and the restless. This portion sponsored by Coast Deodorant Soap. That crisp, invigorating scent brings you back to life.